Alright, so this is question B1 from 2010. It's the soccer stadium. So it's asking us A, to draw the given plan, B, make a perspective drawing structure of the structure given the following. So the spectator point is 1.8 meters away from S. So once you've located that spectator point, 45 degrees from that corner, you're done with this blue line. That blue line is only telling you where S is. It has nothing to do with the rest of the drawing. Picture plane is touching corner A, since once we find the picture plane, it's going through corner A. Horizon line, once we find the ground line, is 2 meters above the ground line. Okay, so the first thing is draw the plan. So to draw the plan, scale 1 is to 20. So the easiest way to do that is to convert everything to millimeters and divide it by 20. So 200 becomes 10. You can see a few of them written down there. So convert to millimeters and divide it by 20. If it's scale 1 is to 50, convert to millimeters, divided by 50. Okay, so here's our plan here. Here's our S, 45 degrees away. Okay, so I could rub out that line if I needed to. That line is finished with now. So what I need to do now is I need to set up the spectator. So I know the spectator, he's standing there and he's looking at this stadium here, and the roof is at 30 degrees, so it's covering everything underneath. That's why the detail is dotted lines. So I need to figure out, right, what way is that spectator looking? So obviously it's looking at this object, but what direction is the spectator's head? So to figure that out, I take the point on the far left. So he's standing here looking at this. What's the last thing he sees on the left hand side? Well, this corner of the stadium is the last thing he sees, so we'll join that to there. And what's the last thing he sees on the right hand side? Well, it's this corner up here. So I join spectator to that. So that's what the spectator needs to see. So what direction should the spectator's head be to get the best view? Well, the best view would be right in between the farmost right and the farmost left thing. So I bisect that angle to find the direction of the spectator's head. Okay, so I take same distance along this line as this line. Then from there I swing an arc and I swing an arc. And it ends up being just off 45 degrees. Like that. Right, so that is the direction the spectator is looking. Okay, so if the spectator is looking that direction, the picture, anything you look at, any way your head is facing, the picture in front of you is at 90 degrees. So if the spectator is looking at that, well, what the spectator is seeing is at 90 degrees to them. So if we take that direction there, and his picture plane will be 90 degrees to that. So we slide our set square along, and we know it goes through this corner here, corner A. So we'll draw our picture plane. There we go. Okay. Right. So we're set up here. Picture plane done. Okay. Right. So there's the plan of our picture plane. So the spectator is looking at that object, and his picture has been formed on this picture plane here. So there's his picture plane there. Right. So what we need to do is we need to figure out. Right. So the picture has been formed in between there. That's him looking through the picture plane at that corner there. So everything that he needs to see is going to be in here. But obviously for perspective drawing, we need to take that picture plane up and we need to flatten it down up here to show the examiner what he sees. Right, so what we need to do first is we need to set up some vanishing points for the lines in various directions. So in this drawing we've got lines only going in two directions. So we've got a line going this direction, so we've got 3 of them in total, 1, 2, 3, and we've got lines going that direction, of which there are 5. So 1, 2, 3, 4, 5. Right, so we have 2 directions of lines in this drawing. Okay. So to find the direction or the vanishing point for lines going that direction, well, we take a line parallel to that. It's our direction, and we take it from the spectator and we draw it up till that hits the picture plane. Right, so now we have the plan of the vanishing point for lines going that direction. Let's put in 2 little arrows on that to show it's parallel. Right, so that red line is parallel to that. Okay, and we need to set up vanishing points for lines going in this direction. So that direction from S, find it on the picture plane. So there's that vanishing point for lines going that direction. Right, so we've our plan of our picture plane set up. So now we need to show what it looks like when we take the picture plane up here and we set it down. Okay, so I think the handiest thing to do now, some of you might turn the sheets right around and have that arrow facing up, but I need to quickly be able to draw lines parallel to this and perpendicular to this. So what I'm going to do is I'm going to set up my sheet so that it's parallel with this edge of my set square, just to make it handy for myself. With an adjustable set square I can do that as well fairly quickly. Right, so just take it off the sheet. Right. Okay. Right, that'll do. Tape that back on. Right, okay, so now it's set up parallel to the edge of my set square, and now this is parallel to my picture plane. Okay, so once I've done that, I'm going to, we're going to take this plane up and sit it down here and flatten it down. So if we take it up, it's going to be parallel to this, and I'm going to put it, I have to fit it on my sheet here, so I'm going to just put it above here. Make sure it fits. Right, so there's my ground line, just beyond my plan, and label that GL. Okay, and I know my horizon line is, according to the drawing, is 2 meters above. So it's 2 meters above, that's 100 millimeters, that's 2,000 meters, 2,000 millimeters divided by 20, which gives me 100 millimeters. So I measure 10 centimeters above, I draw another line parallel to give me my horizon line. Right, hopefully this fits in now. Right, so now I've taken my picture plane up and I flatten it down. I've got my horizon line. I know these vanishing points are on the horizon line, so I project them up to show them above on the horizon. So there is vanishing point on the horizon, and there is the other one I found a while ago. There's that lad on the horizon. Okay, right, so I'll label them. This fella will be, there's my horizon line, and on my horizon line I have vanishing point 1 and I have vanishing point 2. So that one is for lines going in this direction, and that one is for lines going in that direction. Okay, right, so once that's started, I have my picture plane set up with my vanishing points. I need a starting point. So usually your starting point will be something that's against the picture plane. So if this is what the spectator is seeing, whatever he's seeing on that picture plane here, it's right up against it is going to be a true length, and then because it's perspective, as you go back from that picture plane, everything's getting smaller. So we'll start with a height that we have, and the height that we have is this corner, which is called A in the question. Right, so we've corner A. So if we look at this little 3D view of it, we see our corner A here. So we can see from corner A that that front step, this front step here, is right against it. So this line here that's on corner A will appear as its true height, and 200 divided by 20 is 10. So it'll appear as 10 millimeters. Now the rest of these, if you see this little kind of sketch in front of it, they're all gone back from the picture plane, so they're all getting smaller. But if I project these lines out onto corner A, then that's their true height. So if I project this front step up, I know that's 30 above. If I project this step over onto A, that's 20 above. And I'll take these invisible lines back to find what they look like in perspective. Right, so I'll do that. I get this corner A, so I'll project him up, and there he is. I don't know. Right, so there's my corner A. Starting on the ground line and sitting right against the picture plane. So I'll measure up the 3 10s that I spoke about. So we got 10, 10, 10. Okay. Right, so now I've got the heights of the 3 of them lads here in corner A, and I know that the step goes back this distance, then up 10, then back this distance, then up 10, then back this distance. So they're going back in this direction. So if they're going back in that direction, then they're linked to this vanishing point. So I'll take all them heights back to this vanishing point. There's one. That's the next step. So these are these invisible lines that I talk about. There's that step. There's that fella. Okay, right, so I know that this front step is sitting right on the picture plane. So there's there. So that's them sitting right on the picture plane. Okay, so it goes up 10 right against the picture plane. Then it goes back as far as here and goes up another 10. Now where does the spectator see him going up that second 10? Well, we have to find out by joining what the spectator is seeing. So there is the spectator looking at the point I'm looking for, and that's where the spectator sees it on the picture plane. And I'll do the same for the next step. So after that he goes back to here and goes up another 10. So where does the spectator see go up the next 10? Well, he sees it there on the picture plane. And I may as well take this back while I'm at it as well. Okay, so we have a little platform up here. Right, that's the last bit of the steps, right? So here is it going up the next 10. So I can take that up. Here is where it goes up the next 10. Right, so just draw that jumping up the 10. Okay, right, so we have that. Right, so we can finish off the profile of them steps there. Right, so he's going over as far as here, then he's going up to 10. This fella is going over as far as here, then he's going up that 10. Then it gets up to a little platform at the top here, this bit here, and that platform lasts as far as this point here. So that's where it is on the picture plane. I project it up. Right, there's our platform here. Grand. Right, so we've that side bit done. After it gets to this back wall here, we can see that after it gets up to here, it goes up to this height here. Now, obviously that's behind the picture plane, so it's not going to appear as that height. We can see that that height of that back wall there that we spoke about is up 60 in height. Now, it's not 60 when it gets back to here, so we'll project an invisible line up as far as A, going in that direction, and find 60 on that, and then project it back to show what 60 looks like in perspective. So there's that back wall. So we're projecting, we're going to take a line at 60 here and bring it back as far as here to find out what it looks like here. So we're going to take a height of 60 here. So here it is in corner A. There's 60. And there's 60 going. So once we have the height at 60 here, we're going to go back the way with that. So there it is going back to that vanishing point because it's going in that direction. Alright, so there's my line at 60. So I know that that back wall is at that height of 60. Grand. Right, so we're up as far as the back wall. Now we can find the fella here in the back corner. So we'll finish off that side. So I've already taken that back because it's the far most left thing I took it a while ago. So there is that point on the picture plane. Project that up. Right. So now I have the back of the stadium. Okay, grand. Now it doesn't simply go over to here. You can see from the drawing it goes in until it's level with that wall here. So it goes in as far as here, then it goes up a height of 20, and I know what that looks like because it's projected back to here, and then from there it goes at an angle until it hits the ground below this front step, or the back of the front step there. Right, so I just simply fill in that because I have all the heights. So all I'm really working on is a profile on the side of it. It's there, and then till it's level with that, the front. And okay, there's our front step there. Right. So now I have the profile of the side of that. So it's like, just if that was like a cardboard cutout, I've all that done there. Right, so I need to start making it 3D. So to make it 3D, I need to start putting, I need to start working off this direction. So we'll say this front corner here, to finish off that, I need to project lines going out in that direction. So if they're going that direction, then they're going to this vanishing point that we established earlier on. So I'm just going to take all these corners, because I know they all go parallel to the ground in that direction, so they're all going to that vanishing point. Now, I know they don't go on forever, but I'll put them all out to the horizon anyway to begin with. Right, so there they are. Okay. So they're all parallel to the ground, going in that direction. Okay, so if them steps, went on for ages until I couldn't see them, that's where they disappear. But obviously they don't. I can see from my plan that where they stop. So this line here on the bottom anyway, this bottom step goes all the way to the end of the stadium. So we can see this bottom line goes all the way to the back corner there, and then these ones only go until they hit this side wall here. So in our plan, that's the very bottom line goes all the way to the end, and then the rest only go up as far as they hit the wall there, like that. So we'll deal with the bottom line first. So where does the spectator see the bottom line stopping? Well, he sees it here on his picture plane. So project that up. Right, so there's the bottom line. Okay, so that's the bottom line. And then there's kind of a wall going up like that, so I'll just draw it in lightly for now. Okay, so these steps, the top of this step goes till it hits the wall, and that's where the spectator sees it hit the wall, so I'll join that back. Okay, so there it is going through the picture plane, and I'll project that up till it hits the line I'm looking for. Right, so that's that front step. There it is hitting the wall. Okay, so I could project back all these corners. I know that this fella goes in until it hits, that step goes in there till it hits that corner there. But I have this line already, so all I have to do is just draw a line going in that direction till it hits the line I have currently. So from this corner, I know it goes in that direction, so it's going to that vanishing point. So I project it over, and there it is hitting that line there. So once it hits that line, I know it goes up 10, or what a 10 appears to be in perspective, and I have that height already brought in. From there, it goes across till it hits the other lad. So we're up as far as here now. Now it goes over until it hits this line here, which we have already. So there it is going back. And from there it goes up another 10. Right, so we'll start seeing it take shape now. That. Okay, and then once it gets up, so we're up as far as here now, it goes all the way back until it hits that back wall, or right in that corner there, and we have that line to cut it off. So it's going in that direction, so it's going to that vanishing point. So there it is, getting cut off by the wall. Right, grand. So I'll just fill in what we have now. Okay, and then from there it goes vertical line until it hits that height. That was 60. There's 60 at that point. Then the wall goes across. So there is that line going up, and there it is at 60. So there's that back corner. Right, grand. Okay. Alright, so this corner back here is it's like a sloping wall going down till it hits a point here at the front, and we know from a drawing that point here, that so it's going down from 60 and it's going all the way down to 30 here. So back from the picture plane, so it's obviously you can't just measure up 30, but we have a point that's at 30 here, at this point here. So if we take that point at 30 and we bring it all the way over till it hits here, we'll know what 30 looks like at that line there. So if we extend up the part of the wall that we need, right, now we have a 30. So we'll take the height of 30 and we'll bring it across the front until it hits this line coming up here. There's a line going across 30, right, so there's our height of 30 there on the wall. And that. Put as a 30 as well. Okay, so I know it goes from a height of 30 up to a height of 60. So all I have to do is just join the two of these. So that's that first line. So that's the inside of the wall. The outside of the wall, I don't really have anything to guide me there. So if all else fails, I'll go back to my plan. Where does the spectator see that point up here? Well, he sees it there. That's the plan of it. So that's where the spectator sees it. I have the line in which it's on. I just don't know where to stop. So I'll use my plan to do that. So here is where the spectator sees that line stopping. So I'll project him up. And there he is on that line there. Okay. Right. Right, so we're up as far as our height of 60 there. Now, the other thing we've left to do is this sloping roof. So we could get everything here using lines that are parallel to the ground, but can't do it for this unless you drew the elevation. But the handiest way to do it is by using an auxiliary vanishing point, and actually it asks you in the question, use an auxiliary vanishing point, so you don't have a choice. Okay, so what we have is we have these lines here that we need to find. These lines going at 30 degrees. Now, from our plan, we know that that line goes in that direction. That 30 degree line goes in that direction. So it is in some way linked to the vanishing point going in that direction, but we know that it's not parallel to the ground, so we're going to have to do something with it. So it's a line going in that direction. However, the line, if I extend it on that line, it's obviously going to hit below the horizon line. So I have to find out, right, how far below the horizon line is this hitting? So you're actually looking at it in your drawing. You're looking at the line that forms that, but you can't gauge a height of it because you're looking straight down on top of it. So what I have to find is, right, if I took a line and it was going down at 30 degrees, following this path here, that's me looking at it, so it's going right down, 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 and it's hitting the picture plane at a certain distance below this vanishing point. But I have to find out how much. So what I need to do is I need to take that triangle and I need to bring it up so that I'm looking straight at it, and I'll be able to see the 30 degree angle, and I'll be able to see the height below the original vanishing point it hit. So to do that, I'm going to rabat this 30 degree angle that I'm talking. I'm going to rabat it around. So imagine I'm pulling it from underneath and I'm bringing it up here so that I'm looking at it dead straight. So it's I'm looking perpendicular to the plane it's on. So to do that, I get my protractor. Right, so I've got this protractor. I'll put it on this, and I'll mark off 30 degrees. Okay, so there's 30 degrees there. Right. So I draw out 30 degrees. Okay, so there's one angle out to 30 degrees. And I'll go vertically up from where my original vanishing point hit. Right, so there we go. Right, so we're going vertically up from there. And just bring that float to meet it. Alright. Okay, so now we've rabatted that triangle, if you want, that we were talking about. So when I was looking straight down top of it, it was like a triangle. If you imagine, took this as a hinge and it spins around underneath, I was looking straight down top of that line, and I've turned it around to see, right, how far below the original vanishing point does a line at 30 degrees hit? And now I have it. There it is there. So I take that height, I take my compass, and I just transfer that height to below the original vanishing point. Right, so there's that height there, and I mark it below. So it's a line going in that direction, so it's that vanishing point, but it's going down at 30 degrees, so it's that far below. Right, so there's my, and we call that auxiliary vanishing point 1. Okay, so now this is where lines going in that direction at 30 degrees will disappear. So if that's where they are, I know that all the lines on the front of this building go at that angle. So this line is going down at 30 degrees from this corner. So all I have to do is just join it through this vanishing point. This fella is doing the same at this corner through that vanishing point. Now I know that corner, they go up at 30 degrees till they hit corner A. So all I have to do is extend up corner A and I'll find where they cut off. So there's corner A, extend it up, and there it is cutting off the front of the building. Right. So there's our profile there at the side. Completed. So I got my 30 degree lines going up until they hit corner A. Okay, so I'm up as far as here. 30 degrees lines going up as far as here. Now, although they're high off the ground, once we get to here, it is high off the ground, but it's still a line going parallel to the ground in this direction. So if it's going parallel to the ground in this direction, it's the same as the rest of them, which means it's going to disappear at that vanishing point. So I take the front of that building and I transfer it over. So there it is going over to here. There it is going over to here. Now, if the front of that was going on forever, that's where it disappears, but it doesn't. It stops here. So I've already found that point on the ground, but all I have to do is keep going up with it. So it's a vertical line coming up here, so I just keep him going up, right, until it cuts off what I need. Okay. So there's the front. There's the top of that stand there. There might be an advertisement or something like that. Okay, and then that goes down at 30 degrees here, or I can join it here. Hopefully joins. Yeah, you can see there when it joins back to the auxiliary vanishing point, or you can just join it to it, because it's a line going in that direction down at 30 degrees, so it has to hit that vanishing point. Okay, so there it is, completed, except for this fella here. Obviously that's not the side of that isn't cardboard, it's coming in that direction, so underneath there it's going underneath the stand, that direction parallel to the ground, so it's going to this vanishing point. So I'll join it off to this fella here, and he'd keep going until he disappears behind front corner there. Right, so we have our 3D drawing now. Alright, so it all kind of came from finding this profile at the side. So we found what it looked like in that profile in the side. So if you wanted to take it as we'll take it as an orange. So if you take this kind of corner A here, so I'll put it in blue because it's, imagine that's a picture plane there, that's all a picture plane there. So all this sitting against here is blue. So it's right up against that picture plane here. So if we just shade in, your picture plane is all sitting there, everything's behind it, but this front corner is sitting right against it. And then from there, we took, if you imagine this side of it as like a little a plane that we're looking at in plan, so I'll take it as like an orange plane, and that orange plane goes out in that direction till it hits vanishing point 1. So that goes to VP1. So we took all our heights at A and we transferred them back in that direction. So if I made like if I showed the perspective of that plan that I'm looking down on there, that would be the bottom of it running along there. Obviously it goes up forever, but all we needed of it was going up to the top of the building there. So that kind of, this kind of orange plane here, it's sitting against the side of that stadium there. We found all our heights along that orange plane there. We found it on corner A and we transferred them all back, and we were able to kind of unlock the rest of the drawing from that. So all our lines, these are all going along corner A, all these lines here. Alright, so the key to it is getting your true height at A, and sticking to the fact that lines going in this direction parallel to the ground have to disappear here, parallel to the ground have to disappear there. If there's any lines going in that direction that's at another angle, I need to find an auxiliary vanishing point for it. Okay.